Hey guys, this is Dean and this is the Leetcode biweekly contest 112. So this is the first time that I completed a biweekly contest. So let's briefly go through this biweekly contest, and I think relatively it's like a really like an easy contest. So maybe let's start from the last problem. So for the last problem, we are given a directed weighted graph and we just want to return the shortest path between any two nodes. And the only complexity is like there's an operation called add edge. So basically it means we can add an edge between two nodes. And now if we are asked about the nodes, the distance between nodes like from nodes 3 to 1, we should return like a new value. No, nodes 1, 2, 3, we should return a new value, right? Because in the beginning there's like no root between from nodes 1 to nodes 3, and now there is a root. So how should we approach this problem? Let's first look at the constraints. So we will be given maximum 100 nodes, and at most 100 calls will be made for add edge and 100 calls will be made for shortest path. So add edge is not a problem because it's just a O1 operation, right? We will have a hash map to store our graph, and adding an edge to the hash map is just a O1 operation. But this shortest path could be a problem. During the contest, I wasn't very sure if I write a n-square algorithm would it be okay, but finally it is okay. Maybe there's like a better solution, but what I did for this problem is just a simple Dijkstra algorithm, and for each time, like for example, after building this graph, if we are given two nodes like node 0 and nodes, let's say node 2, right? So there are two routes from node 0 to node 2. First one is here, distance is 3, and the second one is here, distance is 5, right? So for if we are given nodes 0, we will just mark the distance of node 0 as 0, and then we will push its neighbors into a priority queue, which is a main heap. And then for every time we will start from the nodes on the top of our main heap, we should be greedy, right? And then we will just traverse through this graph and update our minimum distance for each node, and finally we will find out the shortest path from this starting node to the destination node. So let's look at the code here. Here for this constructor, I just like initialized this adjacency list, which is like a hash map of integer and a pair of vector of a pair of integers. Here I recorded the node and the distance, right? So then I also initialized the number of nodes in this graph as m here. And for the adding edge, which is quite easy, we just add something to our hash map. So this is a O1 operation, right? And then for the shortest path calculator part, I used like a very classical Dijkstra algorithm. So first we will initialize a distance vector, which is like initialized to the infinity for each node. And then we will update the starting node, distance of starting nodes to 0, and then we will push it into our main heap. And then we will like just process this main heap, right? So we will get the top element and we will pop it, and then we will access all its neighbors. And if we find like a shorter path to its neighbors, which means like the current distance plus the cost is less than the previous value we stored in our distance vector, we should just add this next node into our main heap, right? And we should also update it, update the distance. So finally we are done. And in the end, we just need to pay attention, just to be careful, right? If it's still infinity, we shouldn't return this infinity. We should return -1, and otherwise we can return this shortest path, right? So this problem is I think it's not really a very hard problem, and it's relatively easy compared with the previous contest, I believe. So now let's look at the third question. Actually, this question it's not easy, but it took me it took me some time to write up the code because it's I kind of made some mistakes here. But let's go through this problem, and we are given a standard binary tree, and we want to find out the value of each node with the sum of all its cousins values. So the cousin means the nodes in the same with the same depth, but they have the different parents. So for example, here 4 and 9, they have the same depth, but they have the same parent, right? So they have no cousins, so those value will be 0. And for this level, for nodes 1 and 10, the parent is 4, right? And for node 7, the parent is 9. So those three nodes, they are cousins. And for nodes 1 and 10, we should return 7 because they only have one cousin. And for node 7, we should return 1 and 10. 1 plus 10, which is 11, right? Because those two guys are his cousin. So actually there's a quite obvious hint, which is the same depth here. So immediately I came up with the idea of breadth-first search, and I was really just thinking about how should we return the sum of those cousins efficiently, because of course we can get get those nodes level by level, and we can traverse again to see whether they belong to the same parents. If not, we will sum it up, but this will be a n square complexity, right? So here we are given 10 to the power of 5 nodes, which means n to the square n to the power of square complexity wouldn't be okay. So then I just came up with the idea, for example, if we look at this last level, right? We have 10 and 1 and 10 same group, and 7 another group. Here we can have their parent, right? So basically I was thinking about we can use a hash map, and we will have the parent as the key and child in a vector, right? So then we can access those child group by group. For this group, we just want to find out the sum of all other groups, right? So then we just I just came up with the idea we can have a total sum for this level, which is 10, 1, 7, which is 18, right? And then we will have the sum for each group. So here is 11, here is 7. So for this group, what we want to do is just use the total sum minus the sum of its own group, right? So we will return 7, and for this group we will do the same, minus 7, this is 11. So in the end we can just modify those value in place and just return the whole root, right? So here this is my code during the contest, and basically it's quite simple. I believe it's just nothing special. I created a dummy node, a dummy root node, just to make the code a bit cleaner so that we can use the same structure here. I just pushed the root into the queue, and then I did a simple breadth-first search, but by level, right? So we get this size of the queue, and then here we would do a while loop to do something. So here I have some variable to store some information of each level. I have the sum, and I have this I have a hash map. I have this group hash map. So here in the beginning I didn't think about record the sum of each group, so I didn't have this part, and then I realized this would be better. So of course you can put this part, this sum of this group together with this group in a pair together in this line. This would be cleaner, but during the contest I want to finish it in the fastest way, so I just create another hash map, which is not a good practice. So, but the idea is pretty simple. We get the parent, we get the child. Sorry, I made some modification, and we popped it from the queue, and then we just update our hash map and update the sum, right? So the sum will just be the current sum plus this child's value, and then we check whether the child has left child and right child. If it has, we just push them to the queue. And after we process this level, we can process like these two hash maps. We just get the this sum minus its own group sum, and we will modify it in place. And finally, we will return this root, right? So this is a pretty standard BFS problem, but somehow this part took me a while to code it up. So it takes me like maybe like I think 20 minutes to finish this problem. Maybe I couldn't remember. Let's take a look. Yes, it took me like 20 minutes to finish this Q3 and only 18 minutes to finish this Q4. So yeah, I spent some time here, which could be like faster, I guess. So now let's take a look at the problem number 2. Okay. This is a very simple problem. So we are given an array and we want to calculate some score, right? And the score is defined as like this value, this int value plus the maximum value of all previous elements, and then it's, I believe it's cumulated, right? Yeah. Let's look at this example. So for the first index, it's 4 because 2 plus 2 is 4, and for this second element, the maximum value is 3, right? So this score is 3 plus 3, which is 6, and the cumulative is 10, and so on and so forth. So basically, this is just a prefix sum problem, and not even a prefix sum. We just need a value to store like the global maximum value, because we are always iterating this vector in order, right? So then we will just store our cumulative sum, and for each time we just update this max value and we update the score, and which gets the cumulative score, and then it's done. Yeah. So the only thing we need to be careful is about this casting, because here we will return long, right? So you just need to cast them into long, and I think it will be pretty safe and nothing special. So then we can check the first problem, which is a really simple problem. I think it is an easy problem. So basically we are given some 2D array, some grid, and we want to return the length of maximum length of each column. So in the beginning I was a bit confused about this question, what is this length? So for example here, after reading the example, I got it like so for example 333, this is length of 3, and minus 15, this is also length of 3, because there's a minus sign here. And for this problem, like what we want to do is we just write them out like this. This is the example number 2, right? So we just take a look at each column. This is 3, this is like 1, and this is 2. So this is answer 3, 1, 2, right? So here we just need a nested loop. We loop through the column and rows, and then just store our maximum value and get the maximum and just push it into the results, and then it is done, right? So this is a really easy problem, and that's it basically. I think yeah, this is really like I would say a really simple contest, and I hope you guys enjoyed it. And if you like my channel, please follow my channel, and I will upload more videos from time to time.